Hi, my name is Jamie, and today I'm going to be teaching you how to multiply and why the algorithm behind multiplication works for a certain problem. So today, the definition of multiplication is combining many groups of the same size and then counting the result. And I'm going to prove to you why that algorithm or why that definition works by doing this multiplication problem. Another thing to keep in consideration, again, similar to the previous videos, is the idea of conservation and regrouping. So as we can see here, we have 3 rods of 7 each. So if we have 3 groups of 7 each, combining these 3 groups of 7, we get 21. That's also the same as having 3 groups of 4 and 3 groups of 3, because 7 split is 4 plus 3. So if we have 3 groups of 4 each, we get 12. And if we have 3 groups of 3 each, we get 9, because 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we add those two problems together, we get 21, similar to this. So they're just written in different ways, but they are both each equal to 21. So we can remember that as we do this multiplication problem. So if we take the approach at this problem of remembering that these are singles, rods, flats, and supercubes, it's a little bit easier for us. So if we think here, 9 singles times 4 singles. So here we can do 9 singles times 4 singles. We get 36 singles. But when writing it here, we wouldn't write 36 down here because we can't have a 2-digit number. But what we can do is regroup these 36 singles into rods and singles. So if we take 10, 3 groups of 10, so if we take the 30, we get 3 rods, and then the 6 singles left over, and 6 singles, So we would keep these 6 singles down here, and we would carry the 3 rods that we formed out of these 36 singles up into the rods column. Now when multiplying, we need to remember that we multiply each number by each number. So you're going to multiply this by this, and then this by this by this, and this by this. So we'll start with that. So now we're going to take the 4 times the 7, and we add the 3. And you're asking, why do we add the 3? Because we don't multiply the 3, because the 3 are the 3 rods left over from this. So we're just adding those 3 groups of 10 onto the other groups of 10 that we're going to make. So 4 multiplied by 7 is 28, and then we're going to add 29, 30, 31. Going into a further explanation of why the 4 singles times 7 rods plus 3 gets us 31 rods is because, so we do 4 rods times 7 rods, which is 28 rods, plus the 3 rods from the problem above. We get 31 rods, which means rods are groups of 10, so if we did 31 and imagined it as singles, it would be 310 singles. And we have to remember that these are the flats column, or the group of 100 columns. So we have the 3 groups of 100 that we can carry over here, and then leave the 1 there, the 1 rod, or the 10 singles. We would leave that right there. So next, we would do 4 times 3, which is 12, and then we add the 3. So down here we'll do, if we say 4 times 3 flats gets you 12 flats. So 4 times 3 flats gives us 12 flats, and we need to add the 3 flats that we carried over from the previous column, which is going to give us 12, 15 flats. So if we think about flats in a singles form, we would have 1,500 singles. So if we're thinking about carrying again, we know that a supercube, this next column, is made out of 1,000. So we can take this 1,000 out, and we can carry that 1,000 over to the thousands or the supercubes column and leave the 500 or the 5 flats right there. And then if we take 4 times 2, we get 8, and we add the 1, we get 9. So that's all for the first column. And now that we're done with this single, we need to pop a 0 in there to hold our place. And now we have, when you multiply by 0, you get 0. So we can fill in 0 times 9 is 0, 0 times 7, 0, 0 times 3, 0, and 0 times 2 is 0. We can also cross these out if we need to carry in the future. So now we need to mark another space because we're moving over to this place marker. So 2 singles times 9 singles. 2 times 9 is 18. So we can carry the 10 or the rod over to the rods column and leave the 8 singles there. 2 times 7 is 14, plus the 1, so 2 times 7 rods plus the 1 rod would be 15, or, so 15 rods equals 150 singles. So we will keep the 5 rods here and carry the 100 right here. So we have 2 times 3 flats is 6 rods, or 6 flats, excuse me, plus the 1 flat from before. So we have 6, 7. And then the 2 times 2 would be 4. And finally, we finish off our problem using the last column, so we need to mark off. Alright. So we start with the 1 times 9, and then you get 9. 1 times 7, 7. 1 times 3 is 3. 1 times 2 is 2. So now we get all these numbers. What do we do with them? We will add them column by column. So we have 6. I'll come back and give you the answer when I'm done adding. So after adding all these numbers up, we have 6 plus 0 and 0 and 0, so that's 6. 1 plus 0 is 1. 5 and 8 gives us 13, so we carry the 1 up there. 9, so this gives us 10. 19, 24, so we leave the 4 here, bring the 2 up. 7 plus 7 is 14. 15, 16, so we keep the 6 here and carry the 1. 4 plus 3 is 7, plus 1 is 8, and the 2, just bring the 2 down, so we get 2,864,316. So you're asking, why does this algorithm up here give us the answer to this problem? So a multiplication problem is combining many groups of the same size. So if we're combining 1,204 groups, and in each group there is 2,379 in each group. That means we are combining many groups. This is our many groups of the same size, and this is the size of the groups. So we multiply these all together in this long process, and this is our ending result. So that is why this algorithm works on this problem.